Okay, we're going to continue looking at characteristics. This time we're going to look at domain and at our range. And again, remember the hint, if given anything else but a graph, put it into Desmos. You're still doing your domain and range for this graph, so there's your range, there's your domain. I'm putting it into Desmos so I can get a graph so I can see. All right, so I'm going to go ahead and put in my equation as usual. So this right now is a function. How do I know it's a function? Because it says v of x. V in terms of x versus an equation which is just one letter y equals, but it could be anything, like it could be c equals d equals, whereas function notation has the parentheses with two variables. All right, but everything after that is exactly the same. So 8,000 minus 500x. All right, so I put in my equation. I'm going to go ahead and make it a table. Then see, it didn't even appear, right? So I don't want you to use the plus and minus here to zoom in and zoom out. What I want you to do is I want you to go to the last number 2, hold down enter. So like a whole bunch of values came up, and then zoom fit it. When you zoom fit, it will bring it into view, and then you can just zoom in just a little bit in order to see. Okay, so that's the process that I want us to do. So basically what we've been doing in class that folds. All right, now I have a graph, which is the same thing as you. So now I'm finding my domain and range. My graph is going down and your graph is going up. So we just need to know what domain and range is. So domain is x values only from left to right. So what I'm going to ask you to do, since you're on paper, is go ahead and grab a color pencil. Let me pause the video real quick. Grab a color pencil or a highlighter. All right, what I want you to do as you grab your highlighter is I just want you to highlight only your x-axis and the numbers on your x-axis. So I want you to do just what I'm doing on my screen, but on yours. So highlight just your x-axis. That's your domain, right? Only values, but from left to right. So make sure we start at the left and then to. All right, so what I want you to do is just to highlight for your graph just from the left to the right of your x-axis. So I start on the left, this is my x-axis, left and right, and I'm highlighting the numbers and the x-axis. So go ahead and do the same thing for you right here. Once you highlight this, what I want you to ask yourself is, starting on the left, what is the furthest to the left where there is a graph? So if you draw a line up, you put a pencil down, it'd be a lot easier because I can't do a pencil with my. Is there a graph up here? Yes, there is. So that means this graph is even more left of whatever number this is. So this line goes on forever this way, which means it goes on forever this far left. If I'm going left like this, what's happening to the numbers? Like I go 0, then what do I go here? -1, -2, -3, -4, -5, -6, -7, all the way to what number? Negative infinity. So if I need to go all the way left, I'm going to negative infinity. So that's my left side. Then I'm going to keep going right. When do I stop having the graph? So you can see I can have a graph right there. You see how it hits this red line? I have a graph. Here I have a graph. As I keep going this way, what happens? I still have a graph. I'm still hitting a graph. So what's happening to my numbers here? They're going up. So it's 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, like this. And it goes on forever. So if you have a graph that has arrows, right, like this, in other words, it doesn't stop or stop, it means it's going on forever. So this domain, if this was not a real world problem, would be from negative infinity to infinity. Now, I'm just going to talk about quickly just a couple of things, which is basically we need to know open and closed. So I'm going to come in right here. Okay. If I include the number, I'm going to close the bracket between the two numbers left and right. If I don't include it, I'm going to have a parentheses because it's going to be open. Okay. Now, this is one notation. The other notation we're going to see is this, and it's exactly the same thing. The difference being if it's closed, you see the equal sign underneath? That's what is there. But if it's open, there's no equal sign. So a bracket or less than or equal to, greater than or equal to means closed, and then a parentheses and a less than or greater than without the line at the bottom saying equal to means open. In the case of infinity, infinity is not really a number. So positive and negative infinity are not really numbers, so you cannot include them. So for those, it'll be parentheses. Now, here's the problem. In a real world problem, there are limitations. For example, the value can't be, so if it's remember my x-axis is time, right? I can't have negative time. So now what that means is I can't go ahead and include this negative numbers here. So this is all gone. So basically there is no graph from this side. So what I'm going to do actually is I'm going to sketch this here so that we can use this as a reference. All right, so boom, and then it kind of looks like this. Okay. So when I say this is time, this is value. All right, so I cannot have -1, -2, -3. This right here is impossible. There's no such thing as -1 year, -2 years. So what that means for the graph is this doesn't exist. So my first starting point on the left must be the number 0. Okay. Now, further to the right, I also can't have this because I can't have a negative value. Once it's useless, right? I cannot have negative. So that means I can't have the -1, the -2, the -3 over there. So my graph, my rightmost number, and I forgot what that number is. And this is the other thing I like with the dots, is you can just click that and it will stay 16. So you can see my domain is from 0 to 16. And because there's a dot here, meaning there's a line, there's not an open circle. What do I mean by an open circle? Like this, that's open. And then if there's a line or a closed circle, because a line is an infinite number of numbers of closed circles. So if there's a line there, it's like a closed circle. All right, so because there's a closed circle here and here there's a value right there, then these are closed. So my domain, you're highlighting your two numbers on your x-axis, and that's your domain, whether it's open or closed. All right, so I'm going to go ahead and write that down. Now, the other question that you have to ask yourself, because this is a real world problem, is does it include everything inside here? Because this is what this means. So if it says, can I have 0, and go ahead and write years right here and dollars right here and the title machine value. That way you can reference it each time. Can I have 0 years? Yes. Can I have 5 years? Yes. Can I have 16 years? Yes. Can I have 1.5 years? Yes. So because I can have everything within these two numbers, this is how I write domain. Now, if it was, I couldn't have it like it was discrete. So let's say it looked like this instead. It's discrete and I can't have the ones in between because it's not connected. Then I would say it's closed from 0 to 16, whole numbers only, something like that, or positive integers, and then including 0, something like that, to ensure that you're saying not including decimals. Okay, so now go ahead and find out what your domain is. So what is your domain? So you highlighted your X. What's the leftmost number? What's the rightmost number in terms of what makes sense for your problem? And then write it right there. I can see we need to write a mean and in context. So I'm going to go ahead and write a mean and in context, even though I don't have it on my question. So on my question, what does the x-axis mean? So you're looking at just the x-axis, it's the time, right? It's the time that this machine is valued. So all I have to do is include the numbers that I'm saying, so 0 to 16, and then I have to just mention whatever the x value is. So it's the time the machine is valued from 0 to 16 years, something like that. So any kind of abbreviation of that is just fine. Right, so I'm just going to write down the possible number of years, the possible number of years from 0 to 16 since the machine was purchased. Okay, so that's domain. Now we're going to look at range. So same thing, go ahead and take your highlighter, and range is Y values only from the bottom to the top. So what you're going to do is take your highlighter from the bottom to the top and highlight all of these numbers. All right, so I'm going to highlight mine on my paper that I drew because I already know what's counting and what's not. So these are all my numbers, bottom to top. All right, then within the context of my problem, which numbers am I allowed to take? So can I take this? No, my graph is canceled. So can I take here? No. Can I take here? No. The first place I can take is 0. 0, closed. And I'm going to do a different color here so that it doesn't confuse you. Now this way we're looking from bottom to top. So it's a closed bracket with 0. And then what's my top number? So technically the graph does extend, but we just said, we crossed this out and said, hey, this doesn't exist, so you can't put it there. You have to end it here. So I have to go there and see what is my y-axis where it ends. And I go to just that dot, and you can see it tells me that it ends at 8,000. Now I'm going to write this 8,000 sideways so that I can, is it 8,000 or 80? 8,000. So I can put my bracket there. So it's a bracket because it's closed. So you can see my domain is closed from 0 to 8,000. Am I allowed to have decimals? Yes, I can have decimals with dollars. So this is everything included. So again, this is a continuous, actually I'm going to go ahead and say that right now. This is a continuous graph from 0 to 16 and 0 to 8,000. It's continuous in this section in my real life. If it was not continuous, it would mean that I couldn't have the in-betweens, so the decimals. Okay, this would be discrete. So go ahead and write my range. So my range is from 0 to 8,000. What does that mean in context? Again, you're taking whatever the numbers are with what it says. So it's the possible values of the machine as time passes from 0 to 8,000. So we're going to go ahead and say that the possible value of machine, possible value of machine as time passes from $0 to $8,000. Right, so you can go ahead and answer yours as well. For your range, again, we've highlighted your bottom to top. What's your bottom number? What's the top number for the part that exists? And then go ahead and say what it means in context. You're also answering, is yours discrete and continuous? Mine is continuous. Why? Because I can have the values in between. So it's not dot, dot, dot. It's continuous because I can have the values in between, even though it's restricted because of my real life. It's still continuous where it exists. All right, I think that was all the questions. I'm just going to double check. For you, oh, you got one more. So for you, it says write a function. All right, so for me, it gave me the function, but for you, it says write a function. To write a function, what do you need? You need 2 points. But remember, I want you to try and find 3. Let me see if there's 3. Yes, there is. All right, I want you to do 3 points and then always zoom fit to make sure it goes through all the points just in case you pull the points wrong. Okay, so we've done that before. You're going to find, just go this way till you find a corner. That's a corner, put it in. 3 of them, hit flag, and that's your function. Let's practice.